We are going to start now lecture 11 of chapter 7 class 11th mathematics, permutations and combinations. So in this lecture we will talk about some formulas and questions related to the geometrical problems and the counting principles. So the first formula that we have over here, it is that if we have n points in a plane, out of these points no 3 are in the same line except the m points which are collinear. We are being given that we have n points in the plane. Suppose I am talking about these points. We are saying these 4 points, we are saying these are collinear, this is represented by this m, and we are saying except for these 4 there are no other 3 points which are collinear over here. So the total number of different lines obtained by joining these n points is, the formula we have, it is nc2 minus mc2 plus 1. So how we are getting this formula is, we are saying we have total number of points we have, it is n. So if we have to make a line, we are talking about, suppose I am talking about these 2 points, if I have to make a line, it means I am choosing 2 points. So this is that out of these n points, in how many ways I can choose 2 points, it is nc2 ways. Now we are saying that these m points, these are collinear. So with these m points, if I choose these 2 points, I will obtain a line. If I choose these 2 points, I will obtain a line. So by, in how many lines can we obtain from these 2 points, it is mc2 lines. We are saying we have subtracted these mc2 lines from here, and when we have subtracted all these lines corresponding to all these points, we have a line over here. This line we are talking over here, we have a line. We have removed the small lines that we have formed by joining these 2 points. It is line, so we cannot talk about small or larger. We are talking about, suppose I am considering these 2 points, I will obtain a line. If I will consider these 2 points, I will obtain a line. We have subtracted all these lines over here, and one line is there which is passing through all these points, and that one line we have added, this plus 1 is there. So we are saying that this is the formula of total number of different lines obtained by joining these n points. Next is total number of different triangles formed by joining these n points. So we are saying we have to form the triangle, we have to choose 3 points. So there are nc3, and these m points, we are saying these are collinear. So out of these m points, how many 3 points will be chosen? It is mc3. So these 3 cannot form a, these 3 points that we are choosing out of these m points, they cannot form a triangle because they are collinear. So that is why we are subtracting this value over here. Next is total number of different quadrilaterals formed by joining these n points. So again, to form a quadrilateral, we require to choose 4 points. We are saying in how many ways we can choose these 4 points? It is nc 4 ways, and we are subtracting from it the value mc3 into nc1 plus mc4 into nc0. We try to understand these formulas with the help of an example. So suppose we are saying there are 10 points in a plane. Out of these points, no 3 are in the same straight line except the 4 points which are collinear. So how many straight lines can be formed? We are saying we have total 1, 2, 3, 4. These 4 points, these are collinear, and except for these 4 points, no other 3 points, these are collinear. We are talking about the situation in this way. Now when we are talking about the total number of straight lines, so we are saying what we have to do, we have to choose any 2 points. There are total 10 points over here. Out of these 10 points, these 4 points, these are collinear, and no other 3 points, they are collinear over here. So we are saying that out of these 10 points, we are choosing 2 points, it will form the straight lines. Suppose I am saying that we have chosen these 2 points, we will obtain the straight line in this way. We have chosen these 2 points, the straight line will be formed in this way. I am talking about, say these 2 points I have chosen, I will obtain the straight line in this way. Now from this term, we have to subtract the value we are talking about these 4 points, these are collinear. It means I have also chosen 2 points out of these 4. So number of ways of doing so, it is 4C2. It means all the lines formed by joining these 4 points, they are subtracted. Now we are adding 1 over here to add a line which is formed by joining all these 4 points. So the answer we are getting over here, it is, on solving this value we will get, it is 10C2, that is 45, minus 6 plus 1 is equal to 40. In the second case, we are talking about number of triangles. So we are saying that out of these 10 points, we have to choose now 3 points. We have to choose 3 points to form the triangle. We are saying if we choose those 3 points out of these 4 points, how many ways are there to choose these 3 points? Out of these 4 points, it is 4C3 ways are there. So we are subtracting 4C3 because the triangle will not be formed if the 3 points, those 3 points are chosen out of these 4 points. Now coming to the next part, it is quadrilateral. So I am drawing these points again over here, 1, 2, 3 and 4. These are the 4 points which are collinear. These 4 points we are saying these are collinear. We have some other points. So this is the point we have, then this is the point we have, then this is the point we have. Over here we have some point over here, we have some point over here, we have some point over here. We have, these are the total 10 points we have. Now we have to form the quadrilaterals. So out of these 10 points we can choose, there are 10C4 ways in which we can choose any 4 points. Now what we are left over here is, suppose we are saying that we have chosen all the 4 points from here. All 4 points we have chosen from here. So how many ways will be there? It is, we are subtracting from it the value. We are saying all the 4 points they are chosen from here, it is 4C4, and out of these remaining 6 points, no point is being chosen. Next case we are saying, this is one case, we are saying we have chosen 3 points out of these 4 points. We have chosen 3 points out of these 4 points and 1 point is being chosen from the remaining 6 points. Next case, suppose I have chosen 2 points out of this. I have chosen 2 points out of this and 2 from the points which are not collinear over here. I am talking about, I have chosen, this is 1, this is second point, this is third point and this is fourth point. So it will form a quadrilateral over here. So we are not interested in that case. So that is why we are saying that what value we have subtracted, it is 4C4 into 6C0. We are saying all the 4 points are chosen out of these 4 collinear points and no point is chosen from the other point. Next we are saying all the 4 points are chosen, 3 points are chosen from these 4 points and 1 point is chosen from the point except for these 4 collinear points. So the total number of ways we have, it is 10C4 minus 4C3 into 6C1, 4C4 into 6C0, and if you solve this value, the final answer you will obtain, it is 185. So this is the final answer in this case. Now next we have, if there are n points in a plane, out of these points no 3 are collinear. So we have to find the total points of intersection of lines joining these n points. So we are saying we have n points. So from these n points, out of which no 3 are collinear, we are having n points over here, out of which no 3 are collinear. How many lines can be drawn? We know that it is, we have to choose 2 points. So it is NC2. These are the number of lines, distinct lines that can be drawn. And suppose we have obtained, these are the lines we have over here. So what are the cases we have? We are saying either these 2 lines, they may be parallel, or the 2 lines we are obtaining, they may be intersecting. So if we are talking about the total number of point means, over here the total number of point means we are talking about the maximum number of points that we can obtain. We have, what we have to do, out of these lines, these NC2 lines, we have to choose 2 lines. So if how we can choose these two lines? Suppose we are saying this value is P. Now out of these P lines we have to choose two lines, and that will give us the point of intersection. So we are saying the maximum number of points of intersection of these line joining endpoints, it is PC2, where P is the point number of lines that are obtained by joining these two points. And the next result we have is endpoints are the vertices of a polygon. We are having some polygon. Suppose we are talking about these are the endpoints. Then the total number of diagonals that we can have, that is equal to NC2 minus N. So we have already seen this result, this kind of result in our previous lectures. We are saying how we are going to start over here. Suppose we are starting with this particular vertex. We have 1, 2, 3, 4 and 5. We are saying we have to choose two vertices. We are choosing the vertex 1 and 2. We obtain a line over here. If we choose the vertex 1 and 3, we obtain a line over here. If we choose the vertex 1 and 4, we obtain a line over here. If we choose the vertex 1 and 5, we obtain a line over here. I am talking about I have started with 1 and I have joined all these points. Now, similarly, I can start with 2. I can start with 2. I am joining 2 to 3. 2 is already joined to 1. 2 to 4. 2 to 5. Similarly, when I will start with this point 3, 3 is joined to 2, 3 to 4, 4 to 5. These all points are joined. So what we can see is that how many total combinations in which we can choose this point it is. Out of these n points, we are choosing 2 points. The total number of lines we are obtaining, it is this. Out of these lines, these 1 and 2 is joined, 2 and 3 is joined, 3 and 4 is joined, 4 and 5 is joined, 5 and 1 is joined. These are not the diagonals, so we are subtracting the value n from it. These are the edges we have, these are not the diagonals. So we are saying we have the total number of diagonals, it is NC2 minus N. So based upon this, we have the following example. How many number of point of intersection of n straight lines if n satisfies this relation? So we have to calculate the value of n from this relation. So what we have done over here, it is we are starting with this relation, it is n plus 5 p n plus 1. So the value we have, it is n plus 5 factorial divided by n plus 5 minus n plus 1, that is 4 factorial, that is equal to 11 into n minus 1 by 2 into n plus 3 factorial divided by 3 factorial. This value gets cancelled. This n plus 3 factorial gets cancelled over here, and we are left with this n plus 5 into n plus 4. So what we are getting from this 2 gets cancelled over here. So we get n plus 5 into n plus 4 is equal to 22 into n minus 1. And on solving this equation, we will obtain n is equal to 6 or 7. And corresponding to this, we have to calculate the number of point of intersections. We have to calculate the number of point of intersections corresponding to the, these are now the number of lines. This n is equal to 6 and 7. This is basically the value of p that we have. This is important to note over here, that these are the number of lines, that is these are the values of p that we have in this formula. So we are saying the number of point of intersection we have, it is, we are using this result, that it is PC2, so it is 6C2 or 7C2, so it is 15 or 21. We are saying we have 15 or 21 point of intersection. These are the maximum number of points that we can have. Next we have is the interior angle of a regular polygon measures 150 degree each. Then find the number of diagonals of the polygon. So we are saying that if interior angle it is 150 degree each, it means the exterior angle that is equal to 30 degree. So number of sides we have that is equal to 360 by 30, that is equal to 12. So the value of n we have, it is 12. So the number of diagonals we have, the formula we know, we have to choose out of these 12 points, we have to choose 2 points, and we are saying we have to subtract the value 12 that is corresponding to the sides. So the answer we obtain, it is 66 minus 12 is equal to 54. Next is, in a polygon the number of diagonals is 77. Find the number of sides of the polygon. So 77 is the value given to us, it is nc2 minus n, that is equal to n into n minus 1 by 2 minus n. So if we look at solve this value, it is n into n minus 3 by 2. So I can write this 77 as 14 into 11 by 2. So I will obtain the value of n is equal to 14. So these are the number of sides of this polygon. Next is, n straight lines are drawn in a plane such that no two of them are parallel and no three of them are concurrent. Suppose I am talking about the value of n is equal to 2. So we are saying that no two of them are parallel and no three of them are concurrent. I am talking about this thing. If suppose the value of n is 3, I am saying this is one line, this is another line, this is the third line. So what we have to do over here, the number of parts into which these lines divide the plane. So we have to find in how many ways this line is dividing the plane. So if we are considering two lines, you can see that this is the one part, second, this is third, and this is the 4 parts. It divides the plane in the, we are saying corresponding to n is equal to 2, the plane is divided in 4 parts. When we are talking about the 3 lines, we are saying it is 1, 2, 3, 4, 5, and this middle part, it is the 6 parts. We are saying it is dividing it in the 6 parts. If we are talking about just one line, we can clearly see that it is dividing it in the 2 parts. Corresponding to n is equal to 1, we are getting 2 parts are there. So we are saying, suppose we have f of n, this represents the number of parts in which the plane is divided when there are n lines. So what we have is that the value of f of 1 we have, that is equal to 2. The value of f of 2 we have, that is 4. The value of f of 3 we have, that is 6. So suppose I am talking about the case that I have, now suppose I am saying I have these 3 lines in this plane, and it is being given that no 2 lines they are parallel. So if I add the 4th line over here, if I will add the 4th line over here, I am suppose adding this 4th line, this is the 4th line I have added, then what is happening over here is that this 4th line, it is intersecting all the 3 lines. It means when it is intersecting this first line, I am talking about, suppose this is the first line, we are saying when it is intersecting this first line, it is entering from this region, this is region 1 for this, it is entering to the second region. When it intersects second line, it is entering to the third region, and when it is intersecting at this point, it is entering the 4th region. It means this 4th line that I have marked, it is passing through, when it is being marked, it is passing through 4 regions, 4 different regions. So when this line is passing through, suppose I am talking about this region, when it is passing through this region, we are saying it is dividing this region in 2 parts, one is this, second is this. So when this 4th line is being added, we are saying 2 new regions are created, and 1 is deleted. So we are saying if value of f of 3 and f of 4 we are talking about, f of 3 is the number of regions when there were 3 lines, f of 4 is the number of regions when there are 4 lines. So we are saying that f of 4 that is equal to f of 3 minus 3 plus 1 plus 2 times 3 plus 1. We are saying 2 new regions are created and 1 region is being deleted. So on solving this we will obtain that if I write the journal value over here, I am talking about the value. Suppose there are n plus 1 line we have added, we are saying it is equal to f of n plus n plus 1. When you substitute this value over here, you will obtain it is n plus 1. So we have the recurrence relation over here. We are saying the value of f of 1 is equal to 2. And we have the relation that f of k plus 1 is equal to f of k plus k plus 1. And if we solve this recurrence relation, we obtain the final answer in this form. We will obtain the final answer in this form, that the total number of regions we have, it is 1 plus sigma k is equal to 1 to n k, that is equal to n square plus n plus 2 by 2. So these are the total number of regions that we will have. So based upon this, we have this next question. It is, if n lines are drawn in a plane such that no 2 of them are parallel and no 3 of them are concurrent, such that these 3 lines divides the plane in 67 parts, then find the different number of points in which these line will cut. So we are saying the value of this term n square plus n plus 2 by 2 is equal to 67 is given to us. When we solve this quadratic equation, we will obtain two values of n is equal to 11 or n is equal to minus 12. The value of n cannot be minus 12. The value of n cannot be minus 12. So the required number of points we have, it is nc2, that is equal to, corresponding to this, it is 11c2, that is equal to 55. So these are the required number of points in this case. Next is, if m parallel lines in a plane are intersected by a family of n parallel lines, then the total number of parallelograms formed, it is equal to mc2 into nc2. So suppose we are saying that we have, these are the 4 parallel lines we have, these are the 5 parallel lines we have. So if we want to construct a parallelogram, so what we are saying, there are 1, 2, 3, 4 parallel lines, these are 1, 2, 3, 4 and 5 parallel lines. Now if we want to construct a parallelogram, suppose I am choosing this line, line number 2, I am choosing line number 4, then I am choosing this line number 3 and this line number 2. It means out of these 5 lines, if I will choose 2 lines, and out of these 4 lines, I will choose 2 lines, I will obtain a parallelogram. So we are saying the total number of parallelograms formed, that will be mc2 into nc2. That is, 2 we have to choose from the set of n parallel lines and 2 lines we have to choose from the set of m parallel lines. So these are the total number of parallelograms we can form. So the question based upon this is, find the number of rectangles in a chessboard which are not a square. Now we know that when we are talking about a chessboard, how many lines we have? In this direction we have 9 lines, in this direction we have 9 lines. There are total 64 boxes, small boxes we are talking about. Now we are saying the total number of rectangles that can be formed. The total number of rectangle means we have to choose 2 lines out of these parallel lines, we have to choose 2 lines out of these parallel lines. So the answer we will obtain, it is 36 square, that is equal to 1296. These are the total number of boxes, rectangles that can be formed. Now we have to subtract, we are saying they are not square. So when we are talking about not square, so it means we have to calculate the number of squares over here. Now to calculate the number of squares, I am talking about this condition. We have, this is suppose the chessboard, we are saying we are having in this form, some lines are there and some lines are there. Now when we are talking about the squares, so method to choose the square is we can choose this one square, then we can choose this second square. So what we are saying over here, that we have chosen this line, we have chosen this line. We are talking about this is 1, 2, 3, 4, 5, 6, 7 and 8, and total 9 lines are there. Then 1, 2, 3, 4, 5, so on up to 9 lines are there. So we are saying that when we are choosing the square, we are talking about one this small square over here. So how many such squares can be chosen? 8 can be chosen in this way and 8 can be chosen in this way. So total number of squares, these small squares consisting of just one small square, 64 squares can be chosen. Next we are talking about, suppose we are considering the square in this of this size. How many such squares can be chosen? We are talking about, we have chosen a square of this side. So how many such square can be chosen? If I am moving in this direction, I can choose the numbers from 1 to 3, 2 to 3, we can choose 2 to 3, then we can choose 3 to 2 to 4, then 3 to 5, then 4 to 6, then 5 to 7 and 6 to 8. So 1, 2, 3, 4, 5, 6 and last we will have it is 7 to 9. I am talking about how the squares we can choose. This is the first square we can choose, second we can choose in this way, third the next one we can choose corresponding to the next term. Similarly in this other direction we are talking about similar options are there. So the total number of options we have it is 1, 2, 3, 4, 5, 6 and 7. So we are saying how many squares of the dimension 2 cross 2. If we are taking the dimension of each square as unit square of 2 cross 2, it is 7 into 7 squares can be chosen. Similarly of the dimension 3 cross 3, 6 cross 6 can be chosen. So this thing is mentioned over here. We are saying the number of squares we have it is 8 into 8. These are small squares we are saying. Then by combining two squares we can choose 7 into 7, 49 squares, then 36 square and last it is one square, that is this complete large square we are talking about. This is the one square we are considering, that we are considering all the sides over here. So the total number of squares we have it is 204. So we are saying that the required number of rectangles which are not square, that is 1092. These are the required number of triangles which are not square. Next result we have is, if n parallel lines are intersected by another n parallel lines, then the number of rhombus we have it is equal to sigma n minus 1 square. So this formula we have already understood over here. What we are saying, sigma n minus 1 square means this value we have seen over here, that it is 7 into 7 minus 6 into 6 into 5 minus 5 into 5. These values we are talking over here. And if we solve this value, the answer we obtain it is n minus 1 into n 2n minus 1 by 6. So these are the number of rhombus that we will have. That is, they have the equal, the size, the length of their sides it is equal. Now next we have, suppose we are given a square of size n cross n and we have to find how many number of rectangles of any size can be obtained. Suppose I am talking about a square and its length is say 2 cross 2. So if its length is 2 cross 2, it means we have 1, 2, 3 lines over here and we have 1, 2, 3 lines over here. Now I want to calculate the number of rectangles I can have. So the number of rectangles means out of these 3 points, I have to choose 2 points. Out of these 3 points, I have to choose 2 points. Now suppose in place of these 3 points, We are saying the side we are considering it is 2. Then we have 3 lines over here. If we are considering the side as n, so we have n plus 1 lines, and out of these we have to choose 2 lines, and we are doing the square of this term. So the answer we obtain it is n plus 1 factorial, or if we want to remove this factorial, we are saying n plus 1 into n divided by 2 whole square. And we know that this is the formula for sum of the cubes of the natural numbers. So we are obtaining this first result in this form. Next is the number of squares of any side that can be obtained. So if we are talking about the number of squares, then we know that if we have n number of sides, or both the sides these are n, then the formula we have it is sigma n minus 1 square. We are having it is n cross n. So number of sides we have it is n plus 1. Corresponding to this, the answer we obtain, this is sigma n square. You can write this is equal to sigma r square, r is equal to 1 to n. So this is the answer we have in this case. Next is in a rectangle. Now a rectangle is given, and it is given that it is n cross p and n is less than p. The number of rectangles of any size that can be formed, it is n p by 4 into n plus 1 into p plus 1, and number of squares of any side that can be formed, it is equal to this. So we are saying it is, we have suppose 1, 2, 3, 4 so on up to n sides are there. The number of sides we will have it is n plus 1, and these horizontal lines we have it is say p plus 1. So we are saying the number of rectangles we will have n plus 1 c2 into p plus 1 c2. So if you open this term, it is n plus 1 into n into p plus 1 into p, this divided by 2 divided by 2. So the answer we obtain it is n p by 4 into n plus 1 into p plus 1. And in the second case we are saying the number of rectangles or rhombus we will form over here, it is out of these n plus 1 sides, we are saying we have n plus 1 minus r into n plus 1 p plus 1 minus r, and sum of all these terms. This is just the case we have discussed on our previous slide, when the value of n and p they were equal. So similarly we can obtain this result for the case of a square. Next is find the number of rectangle excluding the squares from a rectangle of side 9 cross 6. So the value of n we have it is 6, the value of p we have it is 9. Now we have to find the number of rectangles. So the answer we have it is 7c2 into 9c2. So that is equal to 7 into 6 into 9 into 8 divided by 4. So that is equal to 945. So these are total number of rectangles we have. Now in this question it is being asked that excluding squares. Number of squares we have, it is given by this formula, we have already seen. If you substitute this value over here, you will obtain the answer as 154. So we are saying the final answer we are getting it is minus 154, that is equal to 791. So these are the number of rectangles excluding the number of squares that we will have. Now the next case we have, suppose we have, there are n rows, we are talking about the number of rows we have, it is n, and in the first row there are alpha 1 square. So we are talking about in this first row there are say 2 squares. In second row there are alpha 2 squares, say alpha 1, alpha 2, say there are, this is alpha 2 squares, and likewise in the nth row there are say alpha n squares. Then we have to fill these squares with beta x. We have beta number of x and we want to fill these squares with these x such that each row has at least one x. We have beta number of x. Suppose 1 is placed over here, 2 are there, some 3 are x are there. So the number of ways this can be done, it is equal to the coefficient of x raised to the power beta in, when we are talking about the first row, we are saying that alpha 1 c1x plus alpha 1 c2x square plus so on up to plus alpha 1 c alpha 1 x raised to the power alpha 1. This term, if we are saying, this is in how many ways, the total number of ways we are saying, these coefficients, these are giving us that if we have 1 x, if we have 2x, if we have 3x, if we have alpha 1x, then these are the number of ways in which they can be put in the first row. So if we are saying that we have say beta x, then x raised to the power beta, the coefficient of x raised to the power beta in this expansion, that will give us the number of ways in which it can be placed in, these x can be placed in the first row. Similarly, for the second row, we have this sum. For the third row, we have this sum. And continuing in this way, we are saying in the nth row, we will have this sum. And the product of all these values will give us the final answer. So, based upon this, we have this question. Suppose we have 6x, the number of x we have, it is 6, are placed in the square figure below. This figure is given to us such that each row contains at least one x. In how many different ways can this be done? So, if we are talking about this first row, we are having 6x. So, we are saying it is the coefficient of x raised to the power 6 in 2c1 x plus 2c2 x square. There is no way over here. Next, we are saying this second row is there. After this, we have to choose this second row. The number of ways we have, it is how many? 4c1x plus 4c2x square plus 4c3x cube plus 4c4x4. These are the number of ways, either in the first, then in the second, then we have to arrange it in the third. So, it is 2c1x plus 2c2x square. It is product of all these terms. So, we are saying that if we take x common from this first, x common from this second and x common from this third, we will obtain it is the coefficient of x cube in the expansion 2 plus x square into 4 plus 6x plus 4x square plus x cube, and when we multiply these terms and we obtain that the coefficient of x cube, it is 26. So, we are saying there are total 26 ways over here. Next is in how many ways the letters of the word this D, I, P, E, S, H can be placed in the squares of the adjoining figure so that no two rows remain empty. So, suppose we are saying that a letter X is to be placed over here, and how many letters we have? It is 1, 2, 3, 4, 5 and 6 letters are there. We are talking about if we have 6x, they are to be placed in this, then the number of options we have corresponding to this first one, we will have it is the coefficient of x raised to the power 6 in 3c1x plus 3c2x square plus 3c3x cube, corresponding to this first, third and this. We have cube over here, and corresponding to these two, we will have the term, it is 1c1x square. So, if we take again x common from this, we will obtain that we will have 1 x common from this. So, it is x cube is common from this term. We are saying x cube is common from this first term, and from the second we have x square common. So we are left with this 3 plus 3x plus x square whole cube. This is, we are saying x raised to power 5. So we are looking for the coefficient of x in the expansion of this term. Earlier it was x raised to power 6. Now we are saying it is coefficient of x of this term. So the answer we obtain in this case, it is 81. So 81 ways are there to arrange this x. Now in place of this x, we have d, I, p, e, s and h. Now these 6 letters, these can themselves be arranged in 6 factorial ways. We are saying we have to place x over here. We have placed x 2, 3, 4, 5, say 6. Now what we can do for corresponding to this one particular case, how many arrangements we will have? These 6 letters are to be placed. D can be placed over here, D can be placed over here, D can be placed over here. We have total 6 factorial ways. So the total number of ways of doing this, it is 81 into 6 factorial. So this is our final answer. So these are the required number of ways. Next is the rank in the dictionary. The next topic we have, it is the ranking in the dictionary. So the first question we have is, if the letters of the words are arranged in a dictionary, find the rank of the word airtime. So we are saying, if we arrange these letters, the first letter that will be there when we are arranging them in the dictionary order, it is A, then the letters with E, then with I, then with L, then with R, then with T. So the number of words which begin with AE, we will have it is equal to 4 factorial. We are saying we have total 6 letters, and out of these 6 letters, first 2 we have fixed, it is AE. Now we are left with 4 options, and on these 4 options, the letter, these 4 letters are to be filled. So we are saying there are 4 factorial ways, so we have it is equal to 24. So there are 24 letters which start with AE. Next we are talking about AIE. So we are saying now we have fixed the position of these 3 letters. So the letters that will start with A, I and E. So we have fixed these positions. So we are left with 3 letters now. So we have 3 factorial letters. It is 6. We are saying we have the letters starting with A, E, like this. We have total 24 letters. After all these AE, we have started with the letter AIE. The total number of letters we are saying it is 6 letters. After this, we will have the letters starting with A, I and L. That will be 3, that is equal to 6 letters. Then we are talking about A, I, R, E. There will be 2 factorial, that is equal to 2 letters. Then we are saying we have A, I, R, L. There will be 2 factorial, that is 2 letters. Then we are saying we have the word A, I, R, T, E, L. That is equal to 1 letter. So we are saying the rank of this letter will be sum of all these values. That is 24 plus 6 plus 6 plus 2 plus 1. So the rank of this will be 41. Next is, if the letters of the word are arranged in the dictionary, find the rank of the word docomo. Now the letters we have over here, in this case it is, we have C, D, M, O, O and O. We have 3 O. So the letters which begin with C, the number of letters which begin with C, we are left with 5 options over here, out of which 3 are same. So we are saying it is 5 factorial by 3 factorial, that is equal to 20 letters are there. Then we are saying the letters which start with DC. Answer we will have it is 4 factorial by 3 factorial, that is equal to 4. Then we are saying which start with DM. Answer we will have it is 4 factorial by 3 factorial, that is equal to 4. Then we are saying DOCM. answer we have it is 2 factorial by 2 factorial, that is equal to 1. And last we will obtain it is GOCOMO. The answer we have it is 1. And the final answer we have, the ranking of this letter, that will be sum of all these, that is equal to 30. Next is the gap method. We are discussing over here the case when a particular objects we are given, they are never together. So there are 10 candidates for an examination, out of which 4 are appearing in mathematics and remaining 6 are appearing in different subjects. In how many ways they can be seated in a row so that no 2 mathematics candidates are together? If we have to solve this kind of problem, we are talking about the case that no 2 mathematics candidates are together. So the remaining candidates we have over here, it is 6 candidates are remaining. So we are talking about the arrangement of these 6 candidates. So we are talking about the case, this is 1, 2, 3, 4, 5, 6. These are the 6 candidates we are talking about which have different subjects. Now corresponding to these 6 candidates, we have 1, 2, 3, 4, 5, 6, 7 positions where the 4 mathematics candidates can be arranged. What we have done, we are talking about the remaining candidates. We are saying these can be arranged over here, and now we have 7 positions where these 4 candidates we can make them to sit. Now we are talking about the case that in how many ways these 6 candidates can sit. It is 6 factorial ways are there. And how many positions now we have? It is 1, 2, 3, 4, 5, 6, 7 positions are there. Out of these 7 positions, we have to choose 4 positions where we have to choose 4 positions, so it is permutation. So where we can make these 4 candidates of mathematics, they can sit. So the total number of options we will have, that will be 6 factorial into 7p4. The answer we obtain, it is 720 into 840, that is equal to 604,800. So these are the total number of cases that we will have. So when we have the problems in this form, that the things are, it is being given that these things should never be together. So we will talk about the remaining things and we will find the position at which these can be arranged. Next is find the number of ways in which 5 girls and 5 boys can be arranged in a row if no 2 boys are together. It means first of all we are talking about 1, 2, 3, 4, 5 girls. These are the position for the girls we are saying G1, G2, G3, G4, G5. Now corresponding to these positions 1, 2, 3, 4, 5, 6 positions are there for the boys. So we are saying these girls can be arranged in 5 factorial ways, and these boys, we have the 6 positions for the boys. Out of these 6 positions, we have to make 5 boys sit at these 6 positions. So the final answer we obtain in this case, it is 5 factorial into 6p5. So these are the total number of ways in this particular case. Now next we have is a set A is there and it has n elements. A subset P1 of A is chosen. We are talking about, suppose a set A is there. It has its elements A, B, C, D, E, F. From this set, suppose we have chosen these 2 elements B, C, and we are saying this is the set P1 we have. And the set A is reconstructed by replacing the elements of P1. We are saying the elements of this set P1, they are being replaced. So it is say A, then this element B and C is being replaced. We are saying the elements A, D, E, F are same. Suppose these 2 elements, these are replaced by 1 and 2. And we have chosen another set from this. Say this is the set P2 we have. And likewise we are saying that in this way M subsets P1, P2, P, we have constructed P1, we have constructed P2, and likewise we have constructed another set Pm. We have chosen another subset Pm. Find the number of ways of choosing P1, P2, Pm so that P1 intersection P2 intersection P3 intersection so on up to Pm that is equal to 5. It should be empty. Now if we choose an element, say I am talking about this element A over here. I have chosen this element A from the set A. Then we are saying that either A belongs to Pj or A does not belong to Pj, where the value of j we are saying it is varying from 1 to m. We will have some Pj for which either this A will belong to some of the Pj or A will not belong to any of these Pj's. Now the total number of ways in which we are saying that A belongs to Pj, that is 2 raised to the power m. We are talking about all subsets, that is the number of elements in the power set of this. Now out of all these subsets, if we choose the set P1, all these sets as equal to the set A, we are saying we have one option, there is only one choice in which AI belongs to Pj for all j is equal to 1, 2, so on up to m. That is, we are talking about the case when we are choosing this P1 as the complete set A. In that particular case, P1 intersection P2 intersection Pm, we are saying that will not be equal to 5. So we are saying that we have total number of options we have, it is 2 raised to the power m, out of which one is not favorable to it. This is corresponding to the element A we are saying. These are the number of cases we are saying corresponding to the element A. Similarly, we have 2 raised to the power m minus 1 cases corresponding to this element B. Likewise, we have n elements, so we have 2 raised to the power n minus 1. So it is n times. So the final answer we obtain in this case, it is 2 raised to the power m minus 1 whole raised to the power n. So these are the total number of choices we have in this case. The second part of this question, it is that P1 union P2 union P3 so on up to Pm that is equal to A. So in the same way, we are saying that there is exactly one choice for which AI belongs to Pj for all j is equal to 1 to m, which is not favorable for this. It means we are talking about the empty set. We are talking about the empty set. So we are saying the total number of ways now we have it is 2 raised to the power m minus 1. These are the total number of ways we have in this case corresponding to one element. For the first choice A, we have these many options. Again for the n elements, we will have 2 raised to the power m minus 1 whole raised to the power n. This answer in both these cases. Next is a set A contains n elements. A subset P of A is chosen. The set A is reconstructed by replacing the elements of P. The same conditions are there. A subset of A is again chosen. Find the number of ways of choosing P and Q such that P intersection Q contains exactly R elements. So suppose we are saying the set A we have, it has the elements A1, A2, so on up to An. It has these n elements, that is so on up to n. Now we are talking about the case that P intersection Q contains R elements. So if we are talking about the any particular element of the set A, I am talking about the element AI belongs to A. We have 4 cases. First case is that AI belongs to P and AI belongs to Q. This can happen. AI belong to P and AI does not belong to Q can happen. Third case is there that AI does not belong to P and AI does not belong to Q can happen. And fourth case is that AI does not belong to P and AI belongs to Q can happen. We have these 4 cases for any element AI in A. Now if we look at these choices, We are interested in the choice that ai belongs to P and ai belongs to Q, and we are not interested in the remaining 3 choices, because what we require is that this ai should belong to P intersection Q, that is, it belongs to both P and Q. This set P intersection Q should have R elements. So it means we are talking about in how many ways out of these n elements, we have total n elements in A, we have to choose R elements. The number of ways we will have it is NCR. These are the total number of ways we have. And for each remaining, we are saying we have chosen R elements, and for each of the remaining n minus R elements, we have choices out of these 3 options. So we are saying the number of ways for the remaining elements, it is 3 raised to the power n minus R. So what we obtain from this is, I am again explaining these things. We are saying the number of the ways of remaining elements is 3 raised to the power n minus R. So what we finally get from this is that the number of ways in which P intersection Q contains exactly R elements, it is equal to NCR. NCR is in how many ways these elements can belong to this first case. These elements, they are belonging to this first case, and we are saying that the remaining elements, they can belong to these 3 cases in 3 raised to the power n minus R ways. So the answer we have, it is NCR into 3 raised to the power n minus R. Now in the second part of this question, it is P intersection Q contains exactly 2 elements. So it means the value of R is given to be 2. So the answer, if we substitute R is equal to 2, we obtain the answer in this form, that it is NC2 into 3 raised to the power n minus 2. And the last part of this is P intersection Q should be equal to 5, that is, it is empty. It means the value of R is given to be 0. So we are saying the total number of options we have, it is NC0 into 3 raised to the power n, that is equal to 3 raised to the power n ways are there. That is all the elements we are talking about. Either they belong to P, then they do not belong to Q. If they belong to P, if they do not belong to P, they cannot belong to Q. They are not belonging to Q, and this third case. So we are saying that all these n elements we have, they can be arranged in these 3 options. So these are the total number of options of choosing the sets P and Q. Next is sum of the digits. So we are saying the sum of the digits in the units place of all numbers formed with the help of A1, A2, A3, An taken all at a time is n minus 1 factorial into A1 plus A2 so on up to An. And this is the case when repetition of the digits is not allowed. So suppose we have given an example over here. We are saying this: find the sum of the digits in the unit place of all numbers formed with the help of 3, 4, 5 and 6. Now the sum of all these digits, it is 3 plus 4 plus 5 plus 6, it is 18, and the numbers we will have, that will be equal to 3 factorial. Different we are talking about. So it is 6 into 18, that is equal to 108. Now why this 3 factorial is there? We are saying, suppose this 3 is being fixed at the unit place, then how many options we have over here? We have 3 factorial options over here. So likewise, corresponding to 4, 5 and 6, we have these digits. So we are saying the number of terms which end with 3, it is 3 factorial. Number of terms which end with 4, it is 4 factorial. So basically we are saying it is 3 factorial into 3, then 3 factorial into 4, then 3 factorial into 5, then 3 factorial into 6, and the answer we are obtaining, it is 108. Next is the sum of all digits that can be formed using the digits 1, 2, 3, n, so on up to n. Repetition of digit is not allowed. So in this case, First we are talking about the case, the digit which ends with A1. We are talking about the digit which ends with A1. How many options we are left over here? It is n minus 1 factorial ways. So the digit that will be formed, say it is, we are saying that it is ending with A1. Then it is plus 10 times A2, plus 10 times A3, plus 10 times A4, so on up to 10 times AN. This is 10, this is square, this is cube, this is 10 raised to the power n. Next we will have is, next suppose we are saying, we are talking about the digit which is ending with A2. We are saying these digits, these can be interchanged in n minus 1 factorial ways. Then we are talking about A2. So it is 10 times A1, 10 square times A3, 10 cube times A4, 10 raised to the power n times AN. Likewise, we will continue. Now suppose we are writing it in this way, that it is A1 over here, then it is A1 over here, in the next term it is A1 over here, next term it is A1 over here. So if we add these terms, if we add this last term we are talking about, if we are adding this last term, we will have A1 plus A2 so on up to AN. Then it is plus the second last digit we are talking over here, it is 10 into A1 plus A2 and so on up to n. Similarly, we are talking about this first digit, it is 10 raised to the power n into A1 plus A2 so on up to n. If we write this term A1 plus A2 so on up to n common, A1 plus A2 so on up to AN common, we are left with this 10 raised to the power n plus 10 raised to the power n minus 1 so on up to plus 1. This is a GP with common ratio 10. Terms we have, it is n, and the sum of this is 10 raised to the power n minus 1 over 10 minus 1. So that is equal to 10 raised to the power n minus 1 over 9. Then we have this term, and in how many ways these terms can be arranged? It is n minus 1 factorial. So the final answer we obtain, it is n minus 1 factorial. The final formula we have, it is n minus 1 factorial into A1 plus A2 so on up to n into 10 raised to the power n minus 1 over 9. Now based upon this, we have the following question, that find the sum of all 5 digit numbers that can be formed by using the digits 1, 2, 3, 4 and 5. Repetition of digits is not allowed. So by applying the direct formula, we can write the answer, it is 5 minus 1 factorial into 1 plus 2 plus 3 plus 4 plus 5 into 10 raised to the power 5 minus 1 by 9, and the answer we obtain in this form, that it is 3999960. So if we look at the explanation over here, that how we are solving this, we are saying we have these digits. So we are talking about, say these are A, B, C, D and E. We are talking about 1, 2, 3, 4, 5. One number we are saying it is 10 into this, plus 10 raised to the power 2 into this, plus 10 raised to the power 3 into this, plus 10 raised to the power 4 into this. We are saying when 1 is fixed over here, these 4 digits, these can be arranged in 4 factorial ways. We have 4 factorial different numbers which are ending with 1. Then we have 4 factorial different numbers which are ending with 2. This is 1, then this is say 2, say this is say 1, 2. We are writing this is 3, this is 4 and this is 5. We have 10 raised to the power 4, 10 raised to the power 3, 10 raised to the power 2, 10 raised to the power 1. We have 4 factorial different digits over here. Then we are saying we have 4 factorial different digits which end with 3. We are writing it is 10 square plus 10 into 2 plus 10 raised to the power 3, and this is 10 raised to the power 4. This is 4 plus 5 into this. Likewise, we will have 4 factorial digits are there. 4 factorial numbers are there which end with 4, and we will have 10. This term, it is, we are writing 2, 1. Then we should write over here it is 4. Suppose I am saying that this number it is ending with 5, and we are talking about this number 5, and we are talking over here the number ending with 3. So if we add all these values as we have done in the previous case, this is 1 plus 2 plus 3 plus 4 plus 5, then this is 10 into this term, then it is 10 square into this term. So when we add all these terms, we will get it is 10 raised to the power 4 plus 10 raised to the power 3 plus 10 raised to the power 2 plus 10 raised to the power 1 plus 1. Then we have the sum 1 plus 2 plus 3 plus 4 plus 5, and all these terms, these are multiplied with 4 factorial. Sum of these terms, it is 10 raised to the power 4 minus 1 over 9. Sum of these terms, it is sum of all these values, it is 15, and the value of 4 factorial we have, it is 24. So the final answer we obtain in this form. So this is the sum of all 5 digit numbers that can be formed using the digits 1, 2, 3, 4 and 5.